All right, so another way to solve a system of linear equations is by the substitution method. But before we get started, our joke of the day: why should you never talk to Pi? Because he'll just go on and on forever. So when we're using the substitution method, what we're going to do is solve one of the equations for one of the variables. And then whatever expression that we come up for that variable, we're going to substitute it back into the other equation. And that will result in just one variable being in that last equation that we just created. And when we're down to just one variable, then we can solve for whatever that variable is. And then once we solve for one variable, we can go back and put it in and solve for the other variable. And then we can check our solutions. So what we're going to do here is sort of create a T-chart with both of these equations on here. And we're going to solve for each one. So we're given this: y is equal to 5x minus 13. And I'm going to put the other equation over here. 2x plus 3y is equal to 12. All right, well, we're going to always look and see for the easiest variable to solve for. We want to solve for a single variable, one that does not have a coefficient in front of it, a number that's in front of it. So we always want to make sure that we're solving for, I always will say, like our single friend. We always want to take our single friend and go set him up with someone else. We never want to take one of the variables that already has a partner, or one of our friends that already has a partner, and try to go set him up with someone. So we want to take one of the equations. Well, this one is already in, or is already solved for the variable y. So y is equal to 5x minus 13. Well, what we're going to do is that if we know that this is what y is equal to, then we just are going to take this and go stick it in the other equation for the y. So we're going to say 2x plus 3 times y, but we've now determined that y is 5x minus 13. And that is all equal to 12. So you see how that's all we did was stick that 5x minus 13 in for the y variable in this other equation. And it doesn't matter which variable that you solve for. Again, you're just looking for the easiest variable to solve for. So when we're using substitution, it's just really, it's the easiest way as long as one of the variables is a single variable, like he doesn't have a coefficient in front of it. So now all we have to do is make sure we just go solve. And just remember that when these two, when we have that 3y, that means 3 times y. So we've got to make sure that 3 is times the entire y, whatever we substituted in. So we've got to make sure we distribute that 3 to everything. So now we're going to distribute that 3. So we've got 2x plus 3 times 5x is 15x. 3 times 13 is 39. And that's all equal to 12. Okay, so next step, we're going to combine any like terms. To remember, if we go solve for something, we want to make sure both sides are as simple as possible. So that gives us 17x minus 39 is equal to 12. All right, so now we're ready to change signs and move things to the other side. So we're going to add 39 to this side, add 39 to the other side. That gives us 17x is equal to 39 plus 12 is 51. And then we're going to divide by the 17. So x is equal to 3. All right, well, now that we know x is equal to 3, now we're going to take this part and we'll say, okay, well, we know x is equal to 3. So now we're going to go substitute it back in over here and solve for the y variable. So y is equal to 5 times x, which we now know is 3, minus the 13. So y is equal to 5 times 3 is 15, minus 13, so y is 2. All right, so now we've come up with our two solutions, our x and our y. And remember, all those ordered pairs are always written as x value, then the y value. So 3, 2 is the solution to that system of equations. You can go back and check those answers by sticking in 3 for x and 2 for y and just see if those equations are true. All right, we're going to do a couple more examples. If you want to watch one more and then try one on your own, or how many do I have here? 3. You can do that. Set up a t-chart like we did earlier. I'll just work these out. All right, so looking at these, what's the easiest variable in either one of these equations to solve for? Well, I would almost say this one, because over here, because x minus y is 3. Well, x and y are both single friends, but it looks like the x would probably be the easiest one to solve for, because all I would have to do is move over this y. So x would be y plus 3. Okay, I would not solve for the x and y in the other equation because neither one of those are single. We want someone single. So we have x is equal to y plus 3. So we're going to go plug this in now for the x value because that's what x is. So 3 times our x, which is y plus 3, plus 2y is equal to -1. So let's solve for that. Distribute the 3y plus 9 plus 2y is equal to -1. Let's combine our like terms on this side. That gives us 5y plus 9 is equal to -1. We're going to solve for y by subtracting the 9 from both sides. So 5y is now equal to -10. Divide by 5. So y is -10 divided by 5, which is -2. So now we take this value, y is equal to -2. And remember, now we've got to go back over here and solve for this x. So we're going to go put that in for the y on the other equation. So x is -2 plus 3. Maybe I should put that in green so you know where it's coming from. So that means x is +1. So the ordered pair that satisfies this system of equations would be at 1, -2. And so if you were on a graph, that would be the one point where those two lines cross. Okay, so try these next couple on your own and just see how you do. Okay, well notice this equation is already solved for y, so I'm not going to create any extra work for myself by solving the other equation for anything when this is already done. So I'm going to take this one, put it in for the y value right there. plus y, which is negative 3x plus 3. Well, what happens here? We have 3x minus 3x, so that makes 0. So we have 3 is equal to negative 5. Well, that's not a true statement because 3 is not equal to negative 5. So this one has no solution. So what does that tell you about these two lines if they have no solutions? What kind of lines are they? If you said parallel, you are correct. So they are parallel lines, so they are never going to cross. So therefore the answer is no solution. So good job if you figured that one out. All right, let's look at another one. So we have y is equal to 3x minus 4. And we have 9x minus 3y is equal to 12. So again, we're just creating our t-chart. And again, this equation, first equation is already solved for y, so we're not going to create any extra work for ourselves. So we're going to take this 3x minus 4, which is y, and plug it in for the y in the other equation. So that's 9x minus 3 times y, which is 3x minus 4. And that is equal to 12. So 9x minus, make sure we distribute this to everything inside those parentheses, 9x plus 12 is equal to 12. Well, what happens here? That becomes 0 again, and now we're down to 12 is equal to 12. Well, that's true. 12 is equal to 12. So what does this tell us about all these two equations? Well, I can't go stick 12 in for anything over here because 12 is just equal to 12. So that means there are an infinite number of solutions. So these are the same line. If I would have solved the other one, this 9x minus 3y is equal to 12 for y and put it in y equals mx plus b format, I would have came up with the exact same equation on the other side. You could test that if you wanted to and see, but that is the difference in the infinite number of solutions and the no solutions.